Hello, this is Greg Allison with Galactic Greg, just coming to you on 8 June 2020 with some exciting breaking news about a new discovery of a planet and star that are like Earth and our sun in both luminosity, size, distance. This is like a mirror solar system to the one we live in. And the star is Kepler-160, 3,000 light years away from Earth. And the planet is KOI 456.04. What a name, right? KOI. Maybe we should call it koi, right? Like a fish. And maybe a water roll, who knows? But what we know is that this planet is actually 1.9 times the size of Earth, just shy of 2 times. And that's pretty exciting because it orbits in the habitable zone of its star, just like Earth does. And at, say, if it's roughly 2 times the size of Earth, you know, if you do the area of a sphere, what you find is 4 pi times r squared, that it actually has almost 4 times the surface area of planet Earth. That invokes the idea that this planet could have a very large biosphere if it's alive, if it has the opportunity. 4 times, almost 4 times ours. Just imagine that. We have an area 4 times Earth right here. How many nations, civilizations, what kind of microbiomes would you have? What kind of complex ecology would you have? Would it be more robust to survive an asteroid strike? So would species be more robust against extinction level events like we see on Earth? What would it mean for life? What would it mean for the prospects of civilization just 3,000 light years from here? Are they watching us right now? But then we could get into another talk pretty soon about the Fermi paradox, because if there's other civilizations out there, by the time they're very much, not much at all past us in terms of space development, we should be able to see the signs of them in the heavens, the virtual or actual Dyson spheres as they build space habitats and solar collectors around their star. We see nothing of the sort, at least nothing that we can confirm as being that. What does that mean? That's a whole nother line of questions under some topics that we would call Fermi's paradox. I'll do some videos on that. You know, another space channel, Isaac Author, he's probably done dozens and dozens and dozens of videos on that topic, and that's a well that's really deep. And every time you reach down, you can always pull up some new material. But I've got some interesting ideas about that. I may be onto something about that. So let's go back to talking about Kepler-160. Unlike most of the others, so we've already discovered better than 4,000 exoplanets. Most of these exoplanets orbit red dwarf stars, which most of the radiation is infrared. Kepler-160 puts out the visible light, just like we use here on Earth. So plants could be green with chlorophyll to be seen, like we know here. And like I said, it's a very interesting prospect. So if you think about that, let's go back to the red dwarfs. Most of the stars that we found, well, most of the planets we found are like hot Neptunes, the size of Neptune roughly, and much closer to the stars. Not very good, in fact, not at all for life as we know it. They're very close to these stars and they're hotter than all get out. So, and red dwarf stars are notorious for emitting large solar flares, coronal mass ejections, just basically frying the planets in their little solar systems, even if they might be in a habitable zone. It would be a rough place to exist. And also, if you had a planet in one of these habitable zones, it would be subject to tidal heating. You know, you got the planet here, and the other, and as the others going around it, the tug pulling in the crustal material would really heat it up and could create a good bit of volcanism. The most volcanic object in our solar system is the moon, Io, EO, depending on where you're a Carl Sagan follower or how you want to pronounce it. He called it EO, spelled Io, whatever. So the moon Io, EO, EO, orbiting Jupiter is extremely volcanic and replaces its surface, the entire surface of the moon, about every 400 years. That would be a rough place to have a continuous civilization, right? But it wouldn't be there at all. This is a very sulfur-rich planet, moon, and you know, no atmosphere, and it'd be a rough place to exist. All that said, think about, there's several other effects that you would have associated with a planet, even in the habitable zone, orbiting a red dwarf star. For one, it's just like the moon going around the Earth. Now, these are not to scale because the moon would be about the diameter of North America, about 2,000 miles, whereas the Earth is 8,000 miles in diameter. So this is, you know, much larger in comparison. But it's my little moon globe I got when I was a kid, commemorating Apollo landings. So, and this is my little squeezy Earth. Let's hope there's not some big greater crater going, aha, I found a nice squeezed away. Anyway, I digress. I have a little fun. Come on, give me a break. So, if you're orbiting around Earth, eventually the tug of the tidal forces and gravity is going to phase lock the orbiting body, if you're real close, where one side always faces the planet it's orbiting, the star it's orbiting. That's what we see. And that fact, the moon's like that. And the moon is phase locked in such a way that its most dense hemisphere is facing the Earth continuously, kind of a gravity gradient situation. Of course, it might have that density in part because of that tidal lock. In fact, it's been suggested that a planet orbiting a star like one of these red dwarfs may even get a bulge forming on that side that's facing the star. Now, there's other complications involved in that, because if you're orbiting that star, one side of that planet is going to get hot if it's always facing the star. The other side is going to be cold. And so if the planet has liquid water, you're going to like maybe an open ocean on one side and just ice pack on around the rest of it. And it would look like an eye, because the equator would have the biggest opening, and then the ice would be all around. So it would look like an eye, an eyeball. So they're called eyeball planets by conjecture. We've never even seen one at that level of detail, but that's what we anticipate. Now, if it don't have much water, it could be that you're going to have a brown squirt surface on one side. Now, what happens? If there is enough water, it might be that you have on one side an ice pack, and near the periphery, it's always facing the star, it's melting. And then the melt water runs on that side. And if it's a desert, it may be those rivers just evaporate completely. And because it's going to be so hot over there, the air is always going to be an upwelling on that side of the planet. And it's going to leave that side of the planet and go around in huge winds coming around the planet on the backside and coming down over the opposite side, the coldest point, and then coming back over the surface. Which means you're always going to have a cold wind, and the wind's always going to blow in one direction on a planet like pretty much one direction. Now, there might be some vagaries of weather on a more complex planet, and the fact that it does have an orbit around the star, which is pretty fast, on order of a few days, unlike what we have in our star. Then those planets may, in fact, have something of a Coriolis, of course, not as fast as the one on Earth, where the Earth spins once every 24 hours, but that would give you some twist of the winds and some other weather anomalies that we're just not familiar with yet. So these eyeball planets could vary greatly depending on the amount of water, the closeness to the star, and other things. Now, are they suitable for life? We're going to get back to our koi planet in a minute, but in Kepler, we're in Kepler-160. But so let's think about that. The winds may be too high. The winds may be like hurricane force winds, or they may be 1,000 miles an hour. It just may be horrendous. On the other hand, maybe not. There's just several factors, and there's a lot of things that we just don't know. It depends on the composition of the atmosphere, the thickness of the atmosphere, the amount of heating, a lot of things, a lot of variables. Water planet would probably be far more stable than one with less water. And in fact, on a water planet, if it's not boiling a few feet below the surface there, you might have life right there on the eyeball side, maybe. And even a drier eyeball planet off the verge of the habitable zone might also. But we'll have a day-night. It's going to be a very different world. No day-night cycle. Wind's always blowing in one direction. It would be habitable. Most of those planets probably not, due to the flaring of the superflares. And by the way, Actually, the closest exoplanet, planet outside our solar system that we know of, is in orbit around Proxima Centauri. It's Proxima B. Proxima B is actually about 1.1 diameters of the Earth. And Proxima B, though, is, hey, it's probably getting a lot of solar flares because Proxima Centauri actually is a very active flaring star. So it's probably not a good place that you would want to live. So Proxima B is 4.2 light years from Earth, and it has an orbit of 11.2 days. But its mass is 1.2 Earths. Now, the good thing about being around a red dwarf star is, one, there's a whole lot more red dwarf stars than our stars like our sun, and they burn for billions and billions and billions, maybe the life of our universe. They just don't burn out like the hotter burning stars that we're associated with. So they got to have a lot longer time to evolve life. Now, it might be that life would only exist, you know, around a ring, so the biosphere may be very small. Maybe, unless they're water worlds. You know, there's just a lot we don't know, but there's a lot more opportunities around stars like that. And even a planet that might be outside the habitable zone, this large planet with a moon, it's like kind of like Europa going around. Europa is pleased to have twice as much water as we have here on Earth. The tidal forces in a system like that might be conducive to life. So it may well be that most life in the universe, if there is such a thing, may exist indeed around red dwarf stars. Now, but it would be so much different than anything we know. It's really exciting now that we have found something that looks almost like our solar system in terms of a planet that's right around the star. And, you know, so what we're looking at is something that has, let's see, the orbit of KOI 456.404, I should say. How they come up with that, I don't know, is 378 days. Very like our 365 days. Their star, Kepler-160, puts out about, at that planet, where that planet's at, about 93% as much light as our sun puts out on Earth. Very similar, very similar. We don't know about the depth of the atmosphere, what kind of atmosphere it has, or anything like that. Also, a planet that's close to the star, like a red dwarf, may have its atmosphere stripped away and its water entirely by those flares. So they may not have atmospheres or water. Maybe not, unless a lot of comets are coming over. For some reason, they have a magnetosphere. Now, Earth appears to have been impacted by a large protoplanet about the size of Mars early in its inception. So Earth has probably got more iron in its core than it would ordinarily have had, giving us a very robust magnetosphere which protects Earth's atmosphere from the sun. Without it, we may not have an atmosphere today. That, and having the moon locked into us, also gives us the advantage that it keeps the Earth's stabilized so that it don't flip around a lot. You know, we pretty much, you know, spin the same all the time. We got a little wobble, a little precession, but Earth, you know, pretty much spins the same way around the sun all year long with our 27-degree inclination, whatever it is. Not 27, that's whatever. So that said, the inclination gives us our seasons, by the way, not the distance from the sun. All that said, we have the star the star Kepler-160 burns about 5,200 degrees Celsius, which is about 300 degrees Celsius cooler than our sun, which is very comparable. There are 4 planets around that star. In fact, it was 2 of the planets are Kepler-160b and Kepler-160c. In fact, it was the perturbations in 160c that got us looking for the planet that we discovered. So you might ask, Greg, why is it that we know so much about planets around red dwarf stars and we don't see so much around sun-like stars? Well, the answer is the orbital period. Most of our observations, we're not observing a given star for years on end, because you've got to have maybe 3 different transits to confirm that you have a periodicity of that star. Most of what we see in stars And how we see them is the slight diminishment of light as the planet goes around that star. And so we're able to track that. Now, Proxima b was discovered by radial velocity differences. Now, if you look this way, when one body orbits another, both bodies actually orbit around the center of gravity of the two. They're actually kind of orbit together. So what happens is this planet pulls this star just a little bit as it goes, just a little bit. Now, I'm exaggerating it here so you can see what it is. But if it's radial, like we're facing you, and you're on Earth, and this planet is going around, what happens is it goes around the star, is when it comes around on your side, it pulls it. When it comes on the other side, it pulls it back the other way. To you and away. To you and away. Now I'm exaggerating it again. But what you can see is there'll be a Doppler shift in the light. You will see it blue shift, red shift, blue shift, red shift, blue shift, red shift, just by a little bit. If you see that with a periodicity, that's the only explanation, is that there's a planet in orbit around that star. So that's how Proxima b was discovered. Now, you know, there's always some errors. Oh, by the way, there may be a Proxima e, another planet smaller than Proxima b, within the innermost side of the habitable zone of Proxima Centauri. Again, the closest planet, the closest star to our solar system, may have two planets to have those on. Although Proxima e would be a very, very, very hot planet, smaller, probably no atmosphere. Its prospects would be much less. And again, remember, Proxima Centauri is a big-time flaming, flare-tossing star. So, yeah, the prospects there would not be the best in the world as we understand things. Doesn't mean we couldn't go there and dig holes and put up domes and pressurize them and have a heck of a system going there, but I don't know if I'd want to try to terraform it and just have an atmosphere get blown away. Let's ask some question about terraforming Mars. You know, it's not a permanent solution. It may last a few thousand, maybe thousands, maybe millions of years. I don't know. It's not a permanent proposition to terraform a planet that doesn't have a strong magnetic field around the strong star. Now, all that said, again, think about it. Proxima b may have a companion, Proxima e, and we do have our new finding in KOI 456.04, an Earth-like planet 1.9 times the diameter of Earth, which would be, I think it's the diameter, they said size, but I was pretty sure what they're talking about. Orbiting a sun-like star 3,000 light years away. And there may be many, many, many more of those, because those we've not been looking for. Again, why don't we see the red dwarfs? Because the period is so fast, it's easier to watch for them. It's easier to calibrate. In time, we'll be discovering more Earth-like stars, more sun-like stars, Earth-like planets, and a habitable zone. I'm sure maybe far closer than 3,000 light years. There may be a lot of them. Which again begs Fermi's paradox. Oh, what is Fermi's paradox? Fermi's paradox is, you know, given enough time, weren't they here? They should be here. That's Fermi's paradox. But to me, I would say even before they get here, they should be developing structures that we could readily see. So I've got a discussion I want to talk about with that. So again, the Kepler satellite data was the data that we discovered. They're looking for the star KOI 456.04 and around Kepler-160. Now we got a better name for that planet than that. Can you imagine? Where are you from? Oh, I live on KOI 456.04. Yeah, right. Can we get a civilization out there? It's going to have a different name, probably completely. Koi. Koi boy. Anyway, so, but there's been other discoveries of sun-like planets, believe it or not, with, sun-like stars, and planets orbit them. TESS, the Transition Exoplanet Survey Satellite, actually discovered an Earth-like star, I keep saying that, a sun-like star with 4 planets. But in this case, one of them was a hot Earth, which is too close to the star, and there was 3, Neptune-sized planets. But the star It's HD 108236. What are those names again? It's only 211 light years away as opposed to 3,000. So there you go. You know, all kind of potential. All kind of potential. So it's raining sleep out there in space. We're discovering planets and all kind of neat, interesting places. So even though things are looking rough down here on the ground on Earth, there's a lot to look up to, a lot to look forward to out there, if we can ever get there. We've got to survive first. And so, you know, one of the things we've got to do as a civilization survive, if we're really going to get out there, is we have to overcome our hatreds down here. We've got to learn to live with each other. We've got to learn to love one another because of the proliferation of technology and what it can do in our own hands. You know, biotechnology and nanotechnology, proliferation of weapons of mass destruction of other types. The proliferation, especially biotechnology and eventually nanotechnology, could be such that even small groups or individuals could have the capabilities for mass destruction. My buddy Green Griggs has done a video called A Nuke in Every Pot. You should look at that. He's also did a video about the complexity of civilization and why it's really so hard to maintain. These in part may be the answers to why we don't see other civilizations come in here. But I'm going to posit in a future video there may be some other explanations too, maybe galactic explanations. Take it from galactic grades. That might be something to be concerned about. I'm sure Green Grades is going to get interested in this because this falls over into the area of prepping. So, so we'll have to ask Green Grades what he thinks about that, right? Okay, so I've beat this horse enough. What we know today is exciting. We discovered that indeed we have a sun-like star with an Earth-like planet just 3,000 light years away from here. Kepler-160 is the star, and it only runs 300 degrees Celsius cooler than our sun, and its planet KOI 456.04 is 1.9 times the size of our Earth, and it should have a habitable surface almost 4 times Earth's. Wow. You know, I'd like to get out there and check that place out one day. What do you think? You know, 3,000 light years away might take a little time to get out there, so we need to, I need to take care of myself, don't I? Or travel the speed of light. Somehow we'll figure that one out. Or fashion the speed of light. Just get there quicker. Get there before left. Anyway, well, you can support my channel by clicking links I'll put below that which are associated with the Green Grapes channel, because Mr. Green Grapes, he kind of helps me out a little bit, and I help him out. We kind of collaborate on a few things, if you haven't noticed. And I have a fair number of videos on this channel, and I will be doing more. I took a hiatus for a while. I've had some personal issues. I had my father pass, my brother pass. I've had some emergencies regarding my home. Just, you know, everything hits at once, and I've been dealing with some things, and I want to do a video about Apollo 8 lessons not learned. I still want to do a video about Rocketry 101, just explain it in the most simple details for the novice to get a grasp, and then I will get in more and more into rocketry and rocket engines. And I've got a video I'm going to post, not too distant future. I've already got it recorded. I had it recorded months ago, about a 3D printed plasma engine that performs really well, and other co-plasma uses found from this technology, like enhancing the rate of growth of plants. Something my buddy Green Grades will like, right? Yes, there is a synergy of space and green technologies. So I want to say to all you, thanks for listening this time. And just so I'll know that you listened to the whole thing, in the comments below, say, hey, we might have to put some spectacles on our telescopes to see these planets a little better. Let's put some spectacles on. I don't know. That sounds silly, but that's no purpose of it. If it made sense, everybody would get it too easy, right? So we go, why are they saying that? What's that mean? That's stupid. people saying it. They don't come back and watch the whole video, right? I'm not a conspiracy theorist. I am a conspiracy practitioner. And there it is. I got some fun. All right. Thank you, everyone, for watching, and have a great